This video treats the puzzle quad stretches, an intermediate puzzle from July 17th of 2024, and it shows two squares that share a vertex over here, and the midpoints of the sides of the squares are connected like this to form a blue quadrilateral, and those midpoints are connected to those to form a red quadrilateral, and we're asked to find the proportion blue to red. And the approach is more like a algebraic and trigonometric approach, so let me show you how it goes. What I'm gonna do to find the areas of the quadrilateral is I'm gonna split them into 4 triangles which have all the apex in this common vertex A. So if you look at the blue one, you see that this is a triangle. We have here an isosceles right triangle, and there's also an isosceles triangle over here, and we have another triangle over there. And I'm gonna place some angles. Let's say that, and for convenience, that we have here the angle 90 plus x, and it will become later why that is handy. That's that angle. Well, here we have 90, here we have 90, so that leaves that angle to be 90 minus x. Yes. And if I place, let's say, if half of this square side length is A, and we say that this half side length is B, so we have now covered the blue and quadrilateral, and for the red I draw these segments so that the red is also divided in 4 triangles which have the apex at the point A, and I name this angle over here Y, and this is the angle in the 1 to 2 triangle over there, and this angle is also over here, and it's also over it's also over here. Yes, and this is okay, we can leave that. It's 90 minus 2 y. So now we have done the preparations. Let's first focus on the isosceles right triangles. Here for the blue, we can easily see that those two add up to a squared. Let's put it there. A squared divided by 2 plus b squared divided by 2. Oh. So this triangle is a squared, is half, let's say half a square of side length A. This is half square of side length B. Now if I look at the the red triangles, this one, you can see that they have the same base. Yes, that's this base is the same as that one, and the height is exactly 3 times the height of this one. Yes, you can easily find out that this length, this height, is 1/3 of this one. So we have already found that the red add up, the red isosceles triangles, they add up to 3 times that. So 3 over 2 times a square. I have thick fingers today. A squared plus b squared. So what we have already found is that if it were for the isosceles triangles, then the ratio blue to red is 1 to 3. But of course, we still have the other triangles to find out, but we are tempted to the proportion 1 to 3. Okay, now comes the tricky bit. If I look at these two triangles, the leftovers in the blue quadrilateral, then you find that you can easily apply the rule for the area, and that's AB over 2 times, and then sine of 90 plus x plus sine 90 minus x. Where do we have it? Over here. So adding up this triangle and this triangle, you find that this is the expression for their total area. But now, okay, this is very easy. This is the cosine of x. This is also the cosine of x. So this adds up to AB cosine x. So very simple expression for the sum of those triangles, for the blue triangles. Okay, that's for the blue. Now we go to the red. If you find, well, we have to find these side length, and it's because we have here a 1 to 2. We have here a, so it's very easy to see that this has the length a times the square root of 5. And similarly, this has the length b times the square root of 5. And well, this one is exactly the same, so it's also a square root 5. This is also b square root 5. So if we do the same area calculation, we find that it is 5ab over 2 times sine, and then we have 90 plus x plus 2y plus sine 90 minus x plus 2y. And let me show you. So it is this. So this triangle has this side times that side. That makes the AB times 5 divided by 2 times the sine of this angle, and that's 2y plus 90 plus x. And the other one is very similar, only it has 90 minus x plus 2y. And now we're going to use simple trigonometry to find that this is 5ab times sine 90, let's see, 90 plus 2y times cosine of x. That's using an elementary trigonomic rule. And this we can simplify further. Again, we have the sine 90 plus 2y, which is the cosine of 2y. So we have 5ab cosine of 2y times cosine of x. Yes. Well, dy, that's a known angle. That's the angle in the 1 to 2 triangle, and it is not very hard to find. Well, the cosine obviously is 2 divided by square root of 5, and the sine is 1 divided by square root of 5. So you can again use some trigonomic formulas. to find that the cosine of 2y is 3/5. So this calculates to 3/5 times 5, which is times 5, which is 3ab cosine x. Yes, we have used simple trigonomics for that. Okay, and now we can compare. Now we are basically there. We see that this is also exactly 3 times the blue area. So we had already found that the factor 3 is over here. So again we find the factor of 3. So we come to the answer that blue is to red is as 1 to 3.